DevOps at PostSharp with Gael Fraiteur.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. And lots of people are taking me up on my previous offer for a complimentary 30-point DevOps inspection for your custom software .NET environments, and it's helping a lot of people. Also, if you run a user group that has now gone virtual, I'd love to speak at your user group, and there's lots of other people who are raising their hand as well. And if you're tuning in for the first time to the podcast, the Azure DevOps Podcast is for developers shipping software with Microsoft technologies. And my goal for all development teams is for you to be able to move fast and deliver quality and run your systems with confidence. So I'm excited for today's guest. I have with me Gael Fraiteur. He is the founder and CEO of PostSharp, and he's been passionately programming since childhood, building his first commercial application at age 13. And his vision is to build aspect-oriented software that would offer .NET developers the same productivity benefits as those enjoyed by the Java community. And that became a reality when in 2004, he built and released PostSharp to the wild. And PostSharp has steadily grown to become the most comprehensive aspect-oriented software for .NET available today. So, Gael, welcome to the show. How are you, sir?
Hi, thank you. Thank you for having me here. I'm fine. It's a great day, beginning of spring here. Really enjoying.
Awesome. Now, 2004 is a long time ago. How did your career grow that led up to 2004 that brought you into this focus?
So in 2004, I was a frustrated engineer. I was a frustrated .NET developer stuck in an Oracle PL/SQL role, and I needed something better to do, like something more fun to program. So I attacked the best thing I could find at this time, and it was MSIL transformation. And I heard about aspect-oriented programming in Java. There was no good implementation in .NET at the time. There were many bad ones. So what does you do when you are a .NET developer and is frustrated with the PL/SQL job? So I started to code PostSharp, and it took me, say, 1.5 years of work before it actually started to be usable. So the first public version was in 2005, and progressively, it was actually successful. It was hoped, but it was not planned. So progressively, actually, it became a part-time job. During, I guess, 2 or 3 years, I worked half-time and worked still half-time on PostSharp, which was open source at that time. And it grew to the point where a half-time would no longer be sufficient. So I created a company around PostSharp. I created a new version. That was in 2010. In 2010, it was still just me. And then progressively hiring people and building a company, and also a commercial product, which is a totally different thing than a hobby project that you release as open source.
Mm-hmm. And just so that we can fill in the gaps for the listeners, there's some people out there that are thinking, okay, what the heck is this? And I've never heard of the term aspect-oriented before. So what is an aspect?
So an aspect is say something in your code that repeats itself, and you don't really want to write that code, but it's actually necessary. So the hello world example is logging. Typically, you want to log the input parameters of a method and the return value. You want to know if it was successful or if there was an exception. And you would write this code in every single method of importance. And it looks like copy-paste, but it is not copy-paste because you actually need to put all the method parameters to format them properly. So it is kind of robotic programming. You are really doing the job of a robot, but you do it yourself. And I believe, and aspect-oriented programming believes that this is the job of the compiler to do the repetitive work. So with aspect-oriented programming, and PostSharp is one implementation, so you can teach the compiler how to do the repetitive work for you, and the compiler or PostSharp does it. So you say, okay, log me all public methods of this namespace. So logging is a hello world example. Another good example is implementing iNotify property changed. Something that
for WPF.
For WPF, all WPF developers need to do that. And at first sight, it seems to be a little creative because you need to think a little, but it is possible to write an algorithm that does that. Actually, when you are implementing iNotify property change, you are probably looking at properties, looking at fields, mapping fields to properties, like full name depends on first name and last name. Then you're looking at methods that modify first name and last name. And you say, okay, in this case, the update method should trigger a notification of a change of the full name property. But this is algorithmic work, and you are doing that manually, and it is boring, and I believe developers are creative people, and that could be done better. So this is what we are doing. There are other examples like caching or transaction handling or precondition checking, multi-threading, like how do you make a class immutable, freezable, thread-defined. This is all code that just repeats itself. And a machine does that better than you. So that's our role is to implement the software that actually creates that repetitive code for you.
Yeah. Yeah, and especially in applications where CQRS is implemented, or messaging where every command or transaction is wrapped up in some type of event or command, that logging code, if every one of those has a few extra lines of logging just to emit, hey, we're executing this transaction, that's a lot of code throughout some of these large applications that you just have to have in order to emit the right amount of telemetry.
Exactly. So when you write a prototype, you first do not really feel the need for that, except for notify property change where it is necessary. But first, when you move your prototype to production, then it stops to be fun. So programming can be fun, but making an app production worse is more than fun. It's a profession. And we are trying to provide tools to help with that job.
Now, just to go over the product a little bit, PostSharp started as one thing, but now you actually got multiple products listed on the website. Can you give a quick rundown on what's the difference?
Yeah, so I started with just an aspect framework. So an aspect framework is a kind of toolkit which you can create your own aspects. So Aspect framework would provide you with an abstract class, say on method boundary, and then you have a method on entry that is called before your target method, and then you have on exception, on exit, or you have interceptors. So you have this kind of primitive blocks, primitive transformations of code, and with these blocks you can create the aspects. So this is PostSharp aspect framework, and it was what PostSharp 2 was. That was in 2010. But then I realized that all users would recreate the same aspects. And then I started to think, well, let's provide the aspects so that like users don't have to recreate them. And first, I was a bit lighthearted, like, yeah, it's going to be easy. It turns out implementing notify property change for everybody and not just for your app is a pretty difficult job. So there are hundreds of hours in all these aspects. So it is pretty easy to do a hello world, a demo, but doing something that works for hundreds of people, it demands more effort. So we started building these different products. So the framework, this is the basic kit, and on the top of that we have XAML, which implements notify property change and dependency properties, commands, for instance. We have logging that implements logging. We have threading that implements multi-threading models like immutable, freezable, synchronized, reader-writer synchronized. We have the actor model also. The idea there is that you do not need to remember, oh, this field is protected by this lock, so I need to acquire this lock, otherwise I'm going to have a data race. What you are doing is you mark the class as, say, synchronized, and automatically, when you are calling a public method, it is going to acquire the lock that controls this instance. And if by mistake or by hack you are trying to access a field from a thread that does not own the lock, which would cause data race, we are going to raise an exception. So here it is not just about avoiding to repeat yourself. When you apply aspects to multi-threading, you can also change the level of abstraction at which you reason. So instead of reasoning at the level of a field, you reason at the level of a class or even at the level of an interface that you may say, okay, all implementation of these interfaces should be reader-writer synchronized. So that's our threading product.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Hey, this is Jeffrey. Do you ever wonder if your software project is on the right path? It's really common for software projects to experience delays, to have the quality not where it needs to be, or have the team spending more time maintaining the software than you really should. In my practice, we know the challenges implementing all parts of DevOps, and it can make your head spin how many things you have to think about, and somewhere in your gut, you know that something's missing. So I've created a comprehensive 30-point DevOps inspection, reviewing your current process, methods, tools, source control, build integration, the various levels of testing, provisioning and maintaining environments, deploying, logging, telemetry, everything you need to think about in a high throughput, high productivity DevOps environment. And it really helps you gain peace of mind knowing that you're on the right track. And we are offering some more of our really popular 30-point DevOps inspections. And it's normally a $5,000 value, but I'm giving it away for free for my podcast listeners. Just send me an email, jeffrey@clear-measure.com. That's Jeffrey. And I'd be happy to inspect your existing DevOps environment, whether you use Azure DevOps Services, Octopus Deploy, TeamCity, any number of tools, because there are a lot out there. But what's important is that you have a complete and automated DevOps environment put together the right way. So get a second pair of eyes. Send me an email. And threading is complicated. I mean, this is really cool. I'm looking at the website now. The framework is the core, but then all these implementations in and of themselves are pretty sophisticated and hard problems to solve if someone's just going to go and write it from scratch. And with so many, with our industry exploding, that proper threading code is just not something that's in the basic developer bootcamp curriculum. That's something that requires some training and learning to really understand how to not have these types of threading bugs.
Well, I think that now C# developers have problems with threading because like C# has all the primitives that you need to actually create threading code, multi-threaded code. Like so you have logs, you have async, you have threads, and all these primitives. So it's not that it is not possible. The problem is not the technological infrastructure. The problem is really that it's too complex for our brains, that there are so many things to think about at the same time.
Right.
And this is why like functional programming can be such a like have a good argument telling, well, you do not need to think in terms of threading and mutability and logs and so on. You are using your brain CPU cycles for a bad problem. So don't do that, and use immutability, because it is such an easier model to reason about. And this is true. Once you have a model that your brain can use to reason about a problem, you reason in terms of the model. Like when I put my glass on the table, I do not think on the level of atoms. I have a model of a glass, a model of a table. I have models of solid bodies, and I know it's going to stop at the right way position and not going through the table. So I'm not doing micro-analysis. And the same is needed in code. So if you need a thread affine class, all you need is to say that this thread affine class, this class is thread affine, and you should not be forced to think, okay, this method needs to have this piece of code, but this not, and so on. So C# leaves a gap between the way that we are reasoning as developers and the way that we are coding. Like we are reasoning in terms of design patterns, but there is no pattern keyword in C#. So we implement the patterns ourselves, and we are using our intelligence and time and money to do things that the machine, like the pipeline, could do better. So that's the whole idea behind why what we are doing, and it's pretty challenging. That's why we've been spending these 15 years already in
it's a long time
moving there.
All right, so you have developers on your team that are writing new code every day, running tests. The consequences of a bug in a framework piece of software are actually higher than the consequences in an end-user application, because given that you don't own the production environment, you can't just turn around and, let me fix that bug real quick. And so you actually have to have a higher level of quality. Can you give me a rundown of how you think about the DevOps environment for these products and what goes into them?
So our DevOps environment is all hosted on Azure. It is composed of Azure DevOps repositories, only the repo. Then we have TeamCity for orchestration. So the TeamCity is hosted on Azure as a virtual machine. This is the only virtual machine we have for the whole company. All other services run as managed services and not as virtual machines. And then we have a lot of build agents, and most of those are test agents. So we've been gathering regression tests since, I will not say the first year, because the first year I didn't write tests, but we have maybe 13 years of regression tests, starting from .NET 2.
It's probably a lot of tests.
So that's a lot of tests. Our pipeline is that we have a first step is to build artifacts. It will build the PostSharp binaries and prepare everything, and it publishes the artifacts, so zip files. And then we have a number of targets or TeamCity configurations to run the test suites on different platforms. So no, I don't remember how many of those we have, but I think it's over 10 different platforms. So, for instance, we have .NET Framework 4.6 or 4.7, 4.8, so different versions of the .NET Framework.
Yeah.
Then we have .NET Core on Windows, .NET Core on Linux. So the challenge for us is we have to test the build time product, the compiler itself. So we have to test against many versions of Visual Studio, C# compiler, and then we have to test the runtime, because the threading aspects, for instance, they have a lot of runtime components. So sometimes we target a platform with tests that we do not. So at runtime, we target a platform that we do not target or support at build time. So that's also a challenge, because we need to build the test on one platform and then move them to another platform to execute the test. And this was especially challenging before we supported the build on Linux. We supported to run on Linux. So our pipeline is that we build the artifacts in a first step that takes about, I believe, 10-15 minutes. We store the artifacts and then we restore them in all test agents for all the tests. Another target that is not a test target is to produce a distribution. So the distribution are the NuGet packages, the installers. Different steps we have there is to apply the signatures, the code signing signatures, building the IntelliSense files. So this is a separate target.
Mm-hmm. Now, just a point of clarity, if you're developing an application, you would think of a test as an in-unit or an X-unit class with the methods that are the tests, and it executes. But your tests are more like sample applications that all have to be compiled and run, much more in depth for your type of test than just an application test. Can you go over what you think about what comprises some of those test cases?
Yeah, we have exactly these two kinds of tests. So we too have unit tests, and we also have this kind of sample applications. Or unit test coverage for the compiler itself is very limited. It is not the main coverage, but for the aspect libraries, so for logging, for instance, and threading, notify property change, our main tests are unit test, because actually the compiler is already tested in the lower layer, so we do not need to focus specifically on compilation. So the way that we test compilation, we actually have a testing framework, as you mentioned, or as you guessed, because I didn't tell you. We have one C# file for each test, almost. And this C# file has some directives inside. C# commands, we have some escapes, like it is an @ symbol with some directives. And one directive may be expected warning or expected error. This file is not supposed to compile. It is supposed to fail with that specific error or that specific warning. So this is how we test that we actually emit the right warning when you try to add notify property change to a static class, for instance, or these kind of things. We do not just throw an exception, but we tell you something nice, give you some indication about how you fix that. And then, if there is no directive of expected error, we execute the sample, and it is supposed to, the command line program is supposed to return 0. So suppose that we are testing on method boundary. So on method boundary is something that executes before and after the method. So typically, a test would be to have a static string builder on the program class. The aspect class, so the on entry method would append something to the string builder. The on exit method would do the same. We would run the method that has the aspect. After we check that the string builder has the expected value. If not, we return 1. So this is the typical compiler test. And now we have pretty advanced tools to run that. We have a UI, and we have some integration with TeamCity so that we know which test failed. And also we are able to have many test cases in a single test file. For instance, it could be that debug or release build, for instance, could have different outputs, or different constants may be defined. So this is a completely custom testing framework. So why we are doing that is that we are just testing one slice of feature instead of a big file. So we compile a very small thing, which is good. The bad thing is that every test means that we need to run like MS build. That means we are talking of a fraction of a second and not milliseconds.
Right. Now, if someone is developing an application that uses PostSharp, what are the specific things they need to think about when they are authoring tests for their code that is essentially using PostSharp? Typically,
if you are writing aspects for a small team or just for yourself, for say 10 people, you would not invest as much as we do into testing error conditions. That means that you would do unit tests. Also, you don't need to debug the compiler because when it fails, it is our problem. So you would do unit tests. Something that is a point of confusion very often, like people ask, okay, how do you test the aspect in isolation? Because they do not want to apply the aspect to a method. And here I have a kind of comparison. Well, how do you test a method in isolation? Like, how do you test a method without passing the argument it actually expects? You can't. You always need to give the context to the method. Your method you cannot execute without a context. And so the target code is the context of your aspect. Therefore, you always test the aspect applied to a method. So if you have an aspect that has some logic, a conditional logic that depends on the method being static or conditional, you would probably have two tests at least, one with a static method, the other with an instance method. So unit testing just works, just you need to tune your mind a little differently as usual.
Okay. Well, awesome. Well, as we wrap up here, if the listeners are wanting to dig in right away, are there any resources or what direction would you give them for those who want to dig in right away?
So the best way to get started would be to download the community edition. It is free. It includes so a few features are free without any limitation, and all other features, the premium features, are free if you apply them to up to 1,000 lines of code. Then, if you like a feature, you can then use them more, but then you will need to buy a license.
So small applications, in other words, get those for free?
Small applications or just the free features.
Gotcha. Awesome. Well, Gael, thank you so much for coming on the show. This is fascinating.
Thank you for having me here.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.